Hi, hope you are doing well. My name is Supritha. I'm working as a software engineer in programmability area of data center in Cisco system. Today, let us see how automation has completely transformed the networking industry. Thank you. Yeah. Internet is one of the basic necessity. That too, with the COVID-19 situation, we can see that there is a continued increase in online events, virtual conferences, online events, work from home, etc. The continued increase in network speed and scale demands automation. Software automation and data analytics are changing the face of computer networks. Today, we need to deploy a complete networking solution within a span of days compared to months which used to take previously. Also, it is possible now that a single person can configure and monitor hundreds and thousands of complex networking devices which are distributed across a geographical location sitting at a single place. How is it all possible? This is possible because of a key innovation, model-driven programmability. Model-driven programmability has significantly simplified the network automation. I work for data center. First, let us understand what is a data center. In your home, you could have seen something like a small box like this, which provides an internet to your home. You can imagine a data center has something big box which provide a network to a bigger organization or a bigger startups. It occupies one building room. A data center is nothing but a network of computing and storage resources which enables the delivery of shared application and data. Initially, when data center was developed, command line interface was a primary interface through which you can configure and monitor the networking device. A typical command line interface looks something like this. As you can see here in an example, you need to type in a command and it provides you the complete text output like below. For example, you want to know what version of image is running in your system. You type in a keyword show version. It will provide you a complete text output. Now, if you want to set a time, then you need to type in a keyword like clock, set, time, date, and then year along with the time zone. As you can see, this is designed to be more and more human friendly. Human can easily understand and interact with it. But unfortunately, this is not structured and it is not computer friendly. Now, let us say you want to monitor the device. You want to know that, okay, there is some failure in one of the fan. You need to go and dig all the complete log file, search for what fan, what wing is failed. It is a very tedious task. And now let us come to a point where we want to automate the same. If I have to automate it, I want to know what version I'm running here. I need to write a script to search for a string system, then go and get that version string, trim all the unnecessary part and keep only that 5.0.2. It is very, very clumsy. And now let us say in a next release, there comes somewhere else, again the keyword comes with a system. Then your whole script goes for a toss. Again, you need to write a logic to know something that the system which comes off a kickstart, you need to use it. So all in all, automation is impossible or very difficult with command line interface. And also now, it creates a dependency. For example, in a Cisco box, it might be needed that you need to set a time zone first, followed by setting up of a time and a date. In a Juniper box, it might be needed that all this are in a single command where you can set a time, date, and a time zone all in a single command. So this makes that a particular company expert is needed to configure that company device. Cisco expert is needed to configure Cisco device. Juniper expert is needed to configure Juniper device. There is no such a single policy or a single standard which is followed. And also, this is very serial. If you have 100 configurations to be done, you need to type one after the other 100 configurations. Now imagine you need to configure thousands of devices. You need to go and type in all these 100 configurations in all the hundreds. You can imagine how much amount it takes for this to do. And also, this command line interface is error prone. There is a chance that human make a mistake and bring the complete network down, or he can log himself out of a box and there is no way for him to log in again. To overcome all these disadvantages, a model-driven programmability was introduced. A model-driven programmability inherits the power of models, making it easier to configure the routers. It overcomes the drawbacks which is posed by the traditional router management techniques. What is a model? Let us first understand what is a model. You can see here a typical example. A model is a one in which you can specify a syntax, structure, and a constraint of a managed object. For example, in this example, there is a model of a book. There is a book and the book contains following fields like book title, its author, price, and also an ISBN number, which is a unique number to identify that book. So in a model, you specify all the things which are needed. Along with that, you need to specify a structure, like what data type it is. For example, the title would be of alphabetical character, that is nothing but a string. Price will be a numeric or a fraction, which will be represented with a dollar unit. So the model, as you can see, this can be clearly understood by both the computer as well as humans. So this makes it more easier. The tool can understand it easily and it can generate a script for you. You need not write a single piece of code and the tool will automatically generate a script from the model you have written. You can imagine a model as nothing but a blueprint or a contract which a client says on what to be expected from a server side. So model-based way of writing is more programmatic way approach to do it. So what is an YANG? YANG is nothing but a data modeling language which used to specify the model. You need to specify the model, you need some language. That language is nothing but a YANG. YANG is gaining a wide popularity now and it is widely used across the networking industry and all the network devices support YANG model. As you can see, this is a YANG model. Now here many might not even know what is a YANG, but still they can see this and understand what it is saying. Everybody can understand that, okay, this is about a book model and it contains all these details. YANG is rich in its syntax and semantics. It is hierarchical and you can easily extend this YANG model. For example, now you want to include here different formats like whether to support a PDF, EPUB, etc., or a different languages. Then all of this can be added to this YANG model. So it is easily extensible. Along with that, there is a well-defined rule for versioning and rules. Whenever a new version of a YANG model is released, it comes up with a clear set of what is changed, what is new in it, what are the different versions in it, etc. So by using all these details, it makes it more simpler to be used. And by using a YANG model, everything for this is already developed by the applications and you can use this model with just a click of buttons and automation is far more simpler with using a YANG. Now let us understand what is model-driven programmability framework is. A model-driven programmability framework, as you can see, simplifies the network automation. First, it provides models which are rich in a feature. These models are highly structured and programmatic. So this can be very easily used by computers to generate a script. The second part is it separates the transport encoding and protocols from the actual YANG model. For example, at the same time, there were many requirements, like some user wanted to use a netconf protocol along with the SSH transport and an XML encoding. At the same time, there were different users who wanted to use a REST protocol for HTTPS request with a JSON format along with the HTTP protocol. So we need to support all at the same time. How is it possible? So this is possible because you need to separate a model from the transport encoding and protocols. So whenever again a new models are introduced, new protocols or new encodings are introduced like gRPC, protobuf, etc., we are already ready. The same model can be used for different protocols. The third thing is it provides an APIs which completely abstract the internal details from the user. The user need not know how to generate an XML payload or how to write a script to use an netcon protocol, what payload he need to use via REST, via to use a REST protocol, etc. This API internally abstracts all the details and it provides the uh, just provides the abstract details for the user. The user can just by click a buttons like he need an netconf protocol with the XML encoding and an SSH transport. The script will be automatically generated for this. So due to this framework, the automation is becoming faster and much and more simpler. And it is also that we are now ready for different protocols, different encoding, or a different technology that comes in the future also. So this figure clearly illustrates that now how the network modification is progressing. Initially, only 10 to hundreds of 10 or less than 100 of network devices were touched or networks were modified because they were scared of the amount of time it used to take for this deployment. But once the model-driven approach has come into place, we can see that there are like a 5,000, 7,000 number of networking devices are modified across a year. This clearly shows that how much model-driven based framework has simplified the network automation. So let me provide a few tips for our developers. The first, the feature which cannot be automated does not exist. So whenever you are designing a new feature, keep in mind of an automation. The automation is as good as your model and a toolchain you use. So you need to come up with a good model, good toolchain, and also keep in place whenever you're designing a code, how it can be automated. The next thing is to keep in mind is to keep a backward compatibility. Whenever you introduce a new feature, the old feature should not be broken. It has to be intact because the customers will still be using the old features. It takes time for a customer to move to a new feature. So whenever you want to develop a new feature, provide them with the rich documentation, manuals, guides, and also you have also provide them with a sandbox or something where they can go experiment and use your feature so that they can trust your feature and they can use that feature. The next thing is you have to be very, very quick in providing a solutions. If you are slow, then somebody else will come and take your market share and you lose it. So be faster. The next thing is you need to keep six things in mind whenever you are doing a coding. The first thing is it should be reliable, maintainable. You are not the only one person who will be doing the coding. The code written by you should be maintained by somebody else in your team or others. So it has to be understood and it has to be easily extensible. The third thing is it has to be scalable. Now you might have designed only keeping in mind one or two systems, but it can scale later to 100 and thousands of systems. So your code has to be ready where it can scale multiple times. You need to be the quality is most important. You cannot take a chance with that quality. Next is security and also performance. Whenever you do a develop a feature, along with that, you measure the performance of your system so that you will know that, okay, how much delay you have introduced or how much more faster you have made your feature. Next thing, moving forward, let us see how you can move towards this rapidly changing technology. Initially, the days were there where we were using a command line interface. That was later changed to the code XML, and then from XML we moved to the model-based approach. So for all these things, you need to see that how much you can reuse the code. You should be ready that you have to reuse your code, and also you need to modularize it. Only the part of the code which needs to be tested has to be separated from the one which is already tested, so that you will have more confidence You can reduce your testing time and you can provide a solution faster. Think more in object-oriented ways. And also keep up to date with all the third-party source of third-party applications, open source tools, etc. There are various tools like Puppet, Chef, Ansible, which can be used for automation. Keep up to date with that and use the tools which are necessary for your applications. And lastly, automation is a key to success, and network engineers must embrace automation for their success. And automation is as good as your model and toolchain. Thank you. So let me know in case any of you have any questions, let me know. I have shared my contact details in a chat window. I shared my LinkedIn profile as well as my Gmail ID. Please feel free to contact me there. I'll be happy to connect with you. Yeah, let me know. Any of you have any questions? So yeah, if there are no more questions, I'll end the session now. Happy to connect with you. Thank you all.